missing, so I'm trying to record it for them. So we know that the symbol for elasticity is this lowercase epsilon, looks like a backwards 3. And we know that it is the absolute value of my percentage change in my quantity demanded divided by my percentage change in my price. And we know that percentage change we can abbreviate by using the percent symbol and then using the delta symbol, which means change. So the other way that we can represent this, since this means change in price, therefore, the quotient of that, if we divide that by the price, that gives us the percentage change. Similarly, right, we know that change in Q is defined as a change in quantity so therefore we can do a change in Q over Q to define our percentage change. There's no H in percentage. So if we wanted to rewrite this, we could rewrite it as, the change in the quantity divided by the quantity over the change in the price divided by the price. So there's a reason that we're doing this. Let's look at the graphical view of price elasticity very quickly. So we have some demand curve, and we have some point A, and we have some point B. So we're trying to find the elasticity between points A and point B. So if we label this P, then this label here, since this distance is my change in P, that means that this point right here is P minus my change in P. Everybody following me so far with our graphical interpretation? It's going to get a little confusing in a second, so I'm just making sure we're all on the same page here. Got price, The distance between the two is the change in the price. So therefore, the point that is below the change in the price is P minus whatever the change in the price is. Cool? Awesome. Then, similarly, we have at point A, because that's our kind of anchor point. So we're going to put Q at that point A. And then we're going to take a look at how far is B away from Q. Well, it's the delta Q, the change in the Q. So that's going to mean that this point here is Q plus delta Q. Everybody with me so far? Good, 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 good. And we know that the rise over the run, right, the change in the rise over the change in the run, we know that that is what's called our slope, or M, often abbreviated as M. So when we're calculating our elasticity, if we have a graphical kind of interpretation like this, then we're able to use the following identity. So we're going to go from, so we know that this is equal to the elasticity, right? How can we rewrite this to get rid of the dividing sign, the quotient, right? This becomes E is equal to change in Q divided by Q times, anytime we're dividing by something, we can multiply by 1 over it, or multiply by the inverse of it, right? So if we have something that, so for instance, so for this step, we are using the mathematical rule that says that if x over y is equivalent to x times 1 over y. So we're doing the same thing, but instead of 1 over, I keep doing the percentage even though it's a triangle, instead of over 1 over that, right? Whenever we have this, how can we put this in the numerator? We can put this in the numerator by doing what? By flipping it. So this becomes, and let's write it all out again just so it's, percentage. If only I had a little shock collar, and every time I wrote a percentage, it just, then I wouldn't do it anymore. And then times, and so now we're going to put the price on the numerator and the delta price on the denominator, right? So this is a flip of what's happening over here, right? So we're going to take whatever's on the denominator of this lower item here, and we're going to put it on the numerator, and then whatever's on the numerator of this lower item here, we're going to put it on the denominator so that we can flip it and rewrite it, okay? This is just all kind of mathematical identity stuff. There's a reason we're doing this, I promise. So now we're going to use this other mathematical thing which says that if A over B times C over D, that's equivalent to C over B times A over D. that essentially, since they're all, since when this happens, the other kind of thing you can think about is this is equal to delta Q times P over Q times delta P. So anytime you're just multiplying the numerators and multiplying the denominators together. And then you can kind of re-separate them in a different order. So that's what we're doing here. We're using that function to switch the delta Q and the P. So now we're going to have E is equal to P over Q times delta Q, because now my delta Q is going over here, over delta P. And now seeing delta Q over delta P, that should kind of raise a red flag, raise a little alarm for us, right? Because why? That is the inverse of my slope. So the last rewrite that we're going to do using that slope is that the elasticity is equal to the price over the quantity times 1 over the slope. So we don't multiply it by the slope because the slope is delta P over delta Q, right? The slope is not delta Q over delta P. But as we know, the inverse of anything is where we just put the denominator on the numerator and the numerator on the denominator. And so this is what's called our point elasticity formula. So let's do an example before we move on. Well, let's do questions real quick just about the math. You're not going to have to redo this math on the exam. I'm not going to be like, show me the proof of why, you know what I mean? Like, that's higher level, right? If this was like a 300, 400 level class, like maybe, and even then I'd probably have it as like an extra credit question, right? Like, were you paying attention? Can you show me this proof that I took, 13 minutes in class to explain to you, right? But I think it's just like knowing, just understanding that where it's coming from and kind of just like the different, mathematical kind of identities that we're using, right? Just so that we understand that this is the exact same thing. Like we just show that it's exactly the same thing, gives us exactly the same numbers as if we were to do the old kind of calculations that we were doing before in terms of the percentage change over the initial quantity. So let's go ahead and do an example. You may be asked to use this formula in an example on the exam, right? So you may be given some information. You may be told that at point A, you're told that the price is 8, the quantity is 3, and the slope is 20 rise over 5 fall, so it's going to be a 4 slope. We know it's negative slope because it's demand, it's downward sloping. We don't need to say that it's negative. We just kind of assume, right? So the slope, we know it's negative 4 technically, but since elasticity is always positive, elasticity of demand is always positive. We're going to go into other elasticities today that aren't always positive, right? But elasticity of demand is always positive, so we can just kind of drop any negatives that happen just because we know it's an inverted relationship. We know that as price increases, people are going to buy less. As price goes down, people are going to buy more. We know that. So in order to do this calculation, we have all of the things that we need, right? We have, elasticity is my price over my quantity times 1 over my slope. So my price is 8, my quantity is 3, 1 over my slope is 1/4. So we can end up simplifying this fraction a little bit, right? 4 goes into 8 how many times? 2 times. So we can get rid of this 4. So this ends up just being 2/3 or 0.67 rounded. Given this elasticity number, what would we say the responsiveness of consumers to price changes is for this particular product at this particular price? That's the other thing too. Different products are going to have different elasticities along different parts of the demand curve. So we're going to talk about that in a second, but it's just important for us to kind of qualify right now at this particular price, at $8, right? At $8, what is the responsiveness to changes in price for this product? Is it very responsive or not responsive? Not responsive. So it's low, it's inelastic, which means it's not very responsive. Inelastic. Questions on that? Questions on the example? So you will be asked to do an example at least once on the midterm exam. You'll be asked to do an example of the traditional kind of, here's this price, here's this quantity, what's the elasticity, but also you might be, you'll be given a graph, or you'll be given the information about a point and about the slope, and you'll be asked to calculate the elasticity this way as well. Questions on that? We're all good? Okay, pretty simple kind of algebra. Like I said, we're using some identities that maybe we forgot, you know what I mean? Maybe we just haven't used them in a while. But I think I kind of broke everything down in terms of why we made the changes we made along the way, hopefully. But if you have any questions, feel free to shoot me an email. Also, I'm going to put this on YouTube right away. So if you have questions, you can always re-watch this video and this explanation.